I want to start today with a specific mental image. It's a classic, something everyone has seen in one form or another.
Okay.
Think of the legend of St. George and the Dragon. You've probably seen those medieval paintings, you know?
Oh, sure. The knight, the horse, the whole thing, it's iconic.
Right. And when you look at the dragon in those old manuscripts, its anatomy is, well, it's very specific. It's not just some big lizard.
No, it has scales, claws, a really nasty temper, but the most important part, the wings, they're always these big, leathery, membranous wings.
Exactly, bat wings. Now, we all know dragons aren't real. That's, our baseline.
A safe assumption.
But here's where the source material for today's deep dive gets absolutely wild. What if I told you that nature, specifically back in the Jurassic period, actually built something that looks suspiciously like a mini-dragon?
And just to be super clear for everyone listening, we're not talking about a pterosaur here.
Right. Good pull.
Pterosaurs had the leathery wings, sure, but they were a completely different branch of the family tree. We are talking about an actual dinosaur.
A dinosaur. We usually think of, dinosaur to bird evolution as this sort of straight line. You get a raptor, it grows some feathers, it shrinks, poof, you get a pigeon.
Yeah, that's the simplified version we all learn.
But the creature we're looking at today just blows that straight line completely apart. We're looking at a dinosaur that basically throughout the rule book, it didn't want to be a bird.
It wanted to be a bat.
It really is one of the most confusing and counterintuitive discoveries in modern paleontology. We are talking about Yiki.
Yiki. And for anyone wondering, that's spelled Y-I-I, and then the second word is Q-I.
So short. And the name, it's just so direct.
It is. It's Mandarin. Yi means wing, and Ki means strange.
Strange wing.
Literally strange wing.
Yeah.
The paleontologists who named it, Zhu and his team, they didn't even try to get poetic. They just looked at this thing and called it what it was.
I love that. So let's set the scene, because where this fossil was found is almost as important as the animal itself.
Absolutely. This specimen, STM-31-2, it comes from the Tiaozhishan Formation in Hebei Province, China.
And if you're a paleo nerd, you know the Tiaozhishan Formation is basically the Jurassic Pompeii.
That's the perfect way to put it. We're looking at the middle to upper Jurassic, maybe 160 million years ago. This whole area was this lush, temperate forest.
But it was sitting right in the shadow of active volcanoes.
Exactly. So
Yeah.
periodically, you'd get these massive eruptions that would just bury everything in this superfine volcanic ash.
Which is terrible for the dinosaurs, obviously, but incredible for us, because that ash preserves everything.
Everything, not just the bones. It creates an environment with no oxygen, so bacteria can't rot away the soft tissue. You get feathers, skin, membranes.
The outline of the animal.
Yep. Without that specific kind of preservation, what we call a logger state, we never would have known Yiki was special. It would have just been another weird little skeleton in a drawer.
So a local farmer finds this slab. The scientists get it to the lab, they make sure it's not a fake, and they realize they're looking at a Maniraptoran theropod.
Which puts it in the same big family as Velociraptor and eventually modern birds.
But Yiki belongs to a very specific, and I think arguably the weirdest group of dinosaurs out there. The Scansoriopterigidae.
They are the absolute oddballs of the family tree. The name means climbing wings.
And they were all these small tree-dwelling dinosaurs with really bizarre features, like Epidexipteryx.
Oh, yeah. That's another one in the family. No real flight feathers, but it had these 4 crazy long ribbon-like feathers sticking out of its tail, probably for display.
So this family was clearly just experimenting, trying out different ways to live up in the trees.
And Yiki took that family weirdness and just dialed it up to 11.
Let's do the stats first. It's tiny. The paper estimates a body mass of about 380 grams.
So we're talking about the weight of a pigeon.
A pigeon. But it doesn't sound very cute. The skull is described as robust with a really short snout. And the teeth, it says the front teeth were procumbent.
Which just means they angled forward.
So it was snaggle-toothed.
A little bit, yeah. It probably looked pretty scrappy. Not something you'd want nibbling on your finger.
Okay, so we've got a pigeon-sized, snaggle-toothed tree climber. Now for the main event. The arms. Because normally when we find a dinosaur this close to birds, we expect to see feathers, Archaeopteryx, Microraptor.
Right, the feathered wing is the standard model. It's what we're used to.
But Yiki went rogue. The researchers noticed something sticking out from the wrist that, well, it just shouldn't be there. The paper calls it the styloform element.
Such a dry name for something so completely shocking.
I want everyone listening to just hold out your arm for a second. Look at your wrist.
Yeah.
Now imagine a long, bony spike growing out of the side of your wrist, pointing backward.
And it's not a little nub. This rod is actually longer than the ulna, the main bone in your forearm. It's a massive strut.
It's a kickstand for a wing.
That is exactly what it is. And you just don't see that in dinosaurs or birds, but you do see it in a totally different group of animals.
Mammals.
Mammals. Flying squirrels, sugar gliders, even pterosaurs had a similar kind of support bone.
And sure enough, preserved in the rock between this weird wrist spike and the fingers.
Patches of membranous soft tissue. Skin. A leathery wing. The paper describes it as having a sheet-like appearance. So instead of growing long feathers to create an airfoil,
It grew a kite. It stretched a membrane of skin over its arm and this extra bone.
it's a stunning case of convergent evolution. You have this dinosaur trying to solve the problem of getting airborne, and instead of taking the bird route, it independently came up with the bat route.
It breaks your brain a little. You're so conditioned to think dinosaur flight means feathers. And here's Yiki, 160 million years ago, looking like a little gargoyle.
The authors call it extreme morphological divergence. It's proof that nature was trying out all sorts of ideas. The feathered wing wasn't the only option on the table.
It was an era of experimentation.
Exactly. And the picture gets even weirder because it didn't completely give up on being a dinosaur. It didn't swap feathers for skin.
No, it kept both.
Which is what makes the final reconstruction look like a creature from a fantasy novel. It isn't naked like a bat. It's covered in feathers.
But not normal feathers. The paper's microscopic analysis shows they're not the flat, aerodynamic feathers you see on a bird.
Not at all. They found them on the head, the neck, the limbs. But they are described as stiff, filamentous feathers.
And the paper uses this great phrase, paintbrush-like.
Paintbrush-like. So picture a long, thick bristle for most of its length, and then right at the tip, it just sprays out into a bunch of tiny filaments.
So have this shaggy, bristly coat.
A very strange texture. And we can actually go a step further because the study looked at the melanosomes, the little packets of pigment inside the cells.
And the preservation was so good they could tell the difference between the color of the feathers and the color of the wing.
They could. In the feathers, they found mostly eumelanosomes. Those are sausage-shaped and usually correspond to black or dark brown colors.
Okay.
But in the wing membrane, the leathery skin part, they found few melanosomes, which are more spherical and give you reddish-brown colors.
So let's build this thing. A creature the size of a pigeon. Snub-nosed, snaggletooth face. Reddish-brown, leathery bat wings. And its body is covered in stiff, black, paintbrush-like bristles.
It is a chimera. It's something a dungeon master would invent, not something natural selection would.
But it did. It existed.
Yeah.
Which brings us to the big question of physics. Could this thing actually fly?
That's the million-dollar question. The paper is careful, but it says it was definitely volant.
Meaning it could move through the air, it wasn't just stuck on the ground.
Right. But moving through the air is a broad category. A falling brick moves through the air.
So where does yeek fall on that spectrum? Is it a brick or a falcon?
The consensus leans very heavily toward gliding. And the reason comes back to that wrist rod, the styloform element.
The kickstand.
The kickstand. While it's great for holding a membrane open, it creates a huge mechanical problem for flapping.
How so?
Think about how a bird flies. It's all about this incredibly complex, rapid rotation of the wrist. You have to twist the wing on the upstroke and the downstroke to generate lift.
And having a giant bone spike sticking out of your wrist would probably lock that joint up.
It would make it incredibly difficult. The paper suggests it would have interfered with the rapid movements you need for powered flight. It would be just too unwieldy.
So the most likely scenario is it climbed up a tree, jumped, and then glided to the next one.
Exactly. Maybe some clumsy flapping to extend the glide or to slow down for a landing, but it wasn't an aerial acrobat.
Which brings up the big why. Why are we surrounded by feathered birds today and not these bat dinosaurs? This lineage went extinct.
It's a classic evolutionary dead end.
Let's dig into that failure. Is it just that their wrist rod was clumsy, or is there a bigger problem with a membrane wing?
That's a great question. Think about durability. If a bird flies through some thorny branches and rips out a few flight feathers, what happens?
Well, they grow back.
Yeah.
And it can probably still fly even if it's a bit wobbly.
Precisely. Feathers are modular. You can damage part of the system and the rest still works. But a membrane...
A tear in the membrane.
You're done. You crash. A tear compromises the entire aerodynamic surface, and it doesn't heal overnight.
So Yiki was flying around with much riskier, much more fragile equipment.
It was. The feathered wing being developed by its relatives, like Enchiornis, was just a more robust, more versatile, more fault-tolerant piece of technology.
It really was an arms race, wasn't it?
Yeah.
The Jurassic wasn't this static place. You had these different groups all competing for the skies.
An aerodynamic arms race. And Yiki is our best evidence of a path that evolution took that just didn't work out in the long run. It proves the bird body plan wasn't inevitable.
It was just the one that won.
It was just the winner.
It's amazing. And as we wrap this up, I want to come back to the preservation, because to me, that's the most haunting part of this whole story. We only know about these bat wings because of that one specific type of volcanic ash.
That's right. Without the soft tissue, that styloform element would just be a mystery bone. We'd have no idea what it was really for.
Think about how rare that is. Most fossils we find are just bones.
The vast majority.
So how many other dinosaurs sitting in museum collections right now had incredible soft tissue features that we are completely blind to?
It's the question that keeps paleontologists up at night.
Could a velociraptor have had a vibrant throat pouch for display? Could a sauropod have had a short trunk? Could other little dinosaurs have had membranes that just rotted away before they could be fossilized?
It's entirely possible. Yiki is the proof that the skeleton does not tell the whole story. If we only had the bones of this animal, we would reconstruct it wrong.
We'd draw it with feathers on its arms. We'd try to make it look like a proto-bird.
And we would be completely wrong. We would be missing the single most important thing about it. It implies our entire view of the prehistoric world is probably way more conservative than the reality.
The reality was weirder.
So much weirder. More colorful, more experimental, more bizarre than we can probably ever prove.
Yiki is the fossil that looks at us and says, "You think you know what a dinosaur is? You have no idea."
Nature is always more creative than we give it credit for.
So the next time you see a pigeon, remember, that's the safe model. That's the one that survived. But buried back in the Jurassic rocks is a little bat-winged, snaggle-toothed, paintbrush-covered monster that's there to remind us evolution loves to get weird.
Always does.
Thanks for diving in with us.
My pleasure.